Hey guys, here are your rocks notes. So you're first starting out with just a review of your rock cycle that you guys already put together in class. So we're going to talk about how each of those rocks is formed, and then the fact that, of course, they can change from one type of rock to another depending on what kind of conditions they are in. So we're going to start out with our igneous rocks. So igneous rocks are going to come from magma. Magma is molten rock or melted rock. And in that melted rock, there's also water vapor, and it's less dense than the surrounding rock, which allows it to reach the surface. And then we have volcanoes, which we'll talk about in another unit. So that magma is going to contain minerals as well as gases, and it is going to crystallize when it cools. So when it crystallizes, it's going to solidify, and those ions arrange themselves in an orderly pattern. So depending on how quickly the magma cools, we will get some large crystals or some small crystals, or even maybe no crystals at all. So slower cooling will cause large crystals, and fast cooling will cause small crystals. If it's instant cooling, meaning that it's like on the surface and it went like immediately from a magma to solidifying, then we say that it forms a glass or no crystals at all. What is in the magma, what it's composed of, and then the amount of gases that have been dissolved in that magma will give us some different textures as well. Okay, so with igneous rocks, we classify them or put them into categories based on their texture. So that's how big the crystals are, the shape of the crystals, and how they are arranged. So we have 4 types of igneous rock textures. The first one is called a fine-grained texture. And so fine-grained means small crystals that are so small we can't see them unless we have a microscope. So again, small crystals are from fast cooling. So they're going to rapidly form at the Earth's surface. And there are sometimes what we call vesicles or voids, basically these like little holes in the rock, and that's left behind from any gas that was in the magma that has escaped. So it leaves a hole behind. Coarse grain texture is when we have larger crystals, and that's going to be when the magma cools a little more slowly. So that will be if it cools below Earth's surface. So again, cool enough for it to solidify, but not quite above Earth's surface yet. And it's basically this just mass of crystals that look like they've grown together. And when we say slowly forms, we mean really, really slow. Like it says, it could take up to thousands of years for these coarse-grained texture igneous rocks to form. So I will show you some of those. So we're going to start with a basalt. So our basalt is, again, this is an igneous rock. It has fine-grained texture because, as you can tell, you can't see any crystals on it. So you would probably assume there are no crystals, but they're just really small. And then the next one I have is a gabbro. So this one we can tell there are crystals, and then that is coarse-grained because they are large enough for us to actually see them. And then granite is another one that has larger crystals because it's coarse-grained because it cooled very slowly underneath Earth's surface. Okay, so back to our slideshow. Okay, we have 2 more textures. So the next texture is porphyritic texture. So this is kind of like a mix of both fine-grained and coarse-grained. So what happens is we've got magma, it's cooling pretty slowly underneath Earth's surface. So it's getting that coarse-grained texture or that larger crystal texture. And then all of a sudden, if the magma erupts and now comes to Earth's surface, we're going to have small crystals, again, that fine-grained texture. So with porphyritic, we've got most of it is going to be fine-grained or smaller crystals, and then we'll have those larger crystals that are embedded within it. So you have a picture there of a porphyritic andesite. Also, another type of texture we can have, again, from that rapid cooling, so like instant cooling, is that glass or glassy texture. And so we have two examples of that. We've got pumice, and then we've got obsidian. So I will share those with you. So pumice, again, no crystals because it cooled very quickly. And then we've got obsidian, very smooth. This one kind of makes more sense to most students for having a glassy texture because it does look more like glass. But again, very, very small or really no crystals at all because of how quickly it cooled. Okay. So when that magma cools, we know that certain minerals are going to crystallize out of that magma first. So they're going to cool at different temperatures or crystallize at different temperatures. And this was discovered by a scientist called N.L. Bowen. His first name is Nigel. I remember that much, but I don't remember his middle name. But we call this Bowen's reaction series because he's the one that found this out. So he also found that if you have minerals crystallizing at about the same temperature, they're going to be found together in those rocks because they came from the same magma. So we have some pictures here. So it's a little complicated, but we basically see that there are I wanted to do something, but I'm not seeing it, so never mind. So what we see is at the bottom here, we see that quartz is going to crystallize first, and then muscovite, and then potassium feldspar, and then it splits into what we call the discontinuous and continuous series. The continuous series, these are all plagioclase feldspars, but they go from being high in sodium to high in calcium. And on the discontinuous series side, we've got these just separate, totally separate minerals. So we see that quartz will crystallize first, olivine crystallizes last, or our calcium-rich plagioclase feldspars will crystallize last. I think I just said that backwards and I apologize. Okay, let me try again. So the first to crystallize is going to be your olivine and your calcium-rich plagioclase feldspar. Your last to crystallize will be your quartz because it crystallizes at the lowest temperature. Apologies. All right. When we name our igneous rocks, we name them depending on the proportion of light and dark minerals that are in that rock, or really, again, composition, what it's made of. So the first category for igneous rocks is that they can be granitic. Another way of saying granitic is saying felsic. And those are our lightest colored igneous rocks because, as it says, about 90% of the rock has your light colored minerals like feldspar and quartz. Only 10% of it are those darker colored minerals like biotite and amphibole. Rhyolite is our next category. It's kind of its own granitic category, and it kind of has that pinkish color that you see there, and it has some voids or those little holes we talked about, as well as some glass shards. And so this is where it says extrusive, that means that it formed on Earth's surface. If it's intrusive, then it forms beneath Earth's surface. So it's like a granite, except instead of forming underneath Earth's surface to have large crystals, it formed above Earth's surface, and it has fine grain texture or smaller crystals. Our next category based on composition is andesitic, which is also called intermediate. And so those are rocks that are in between, right? Intermediate. So they aren't quite light, they aren't quite dark. So you can see that they're going to have more of those dark minerals like amphibole and biotite, also maybe some pyroxene, so that they'll have a darker color. The next darkest category we have is called basaltic, also called mafic, and that just means now we have a lot of dark silicate minerals, and we have some calcium-rich plagioclase feldspar. Our darkest category is called ultramafic, and that means that it's composed, like it's entirely composed of our dark minerals, like olivine and pyroxene. Olivine is considered a dark mineral, even though it's more of a green color than like a black color, like you would think of for a dark mineral. So just something to keep in mind, that your ultramafic may not be like super dark. It might just be kind of green. So I have a few of those to show you as well. So we're going from basically lighter colors to darker colors. So the first one up, so we've got our granite. So we've seen our granite before. So it's got some dark minerals in it, but mostly light colored minerals. Next, we have a basalt. So this is going to be darker than the granite that we just saw. So this one's basaltic, or mafic. Okay. And then this was our in-between category. So we see pretty equally light and dark minerals there. So intermediate. And then we get to our ultramafic. So this is peridotite. It falls in that ultramafic category because, again, it's composed entirely of dark minerals. Okay, that ends our first video on rocks, igneous rocks.